And then we have, well, explain with the help of suitable example a polar covalent bond. How sweet. We understand what is a covalent bond. A covalent bond is formed by sharing of electrons between two or more atoms, usually two atoms. So say if you have H and you have F. Let us take an example of HF. Fluorine atom has 7 valence electrons, while hydrogen atom has only 1 valence electron. Fine. They decide that we will share it. Lovely, share it. But the story does not end here. Actually, there's a problem. What? Fluorine gets greedy. Initially, might have been that, it was 50-50 sharing. Fine, we'll put electrons, we'll share electrons, we'll put them in between so that I can also enjoy electron presence and you can also enjoy electron presence. Great. But then the moment sharing happens, fluorine says, nah, I'm a gunda, I'm going to take more electrons. So as fluorine withdraws electrons towards itself, please note, the moment electrons are being lost by hydrogen and gained by fluorine, there is some negativity also associated with that. If you loot somebody, you get negative, right? So fluorine is also acting as a, robber. So it will acquire a slightly negative charge, while poor hydrogen will acquire a slightly positive charge. And the moment there is a charge distribution, there's a slight positive, there's a slight negative somewhere, we say, oh my God, there are poles. There is one pole, positive, there is a negative pole. So the molecule is now polar. It doesn't mean North Pole or South Pole of Earth, no. It's no polar bears involved. It is simply a polar molecule, and that's it. So, what is the polar covalent bond? Whenever two atoms having different electronegativities are joined through a covalent bond, always the atom having higher electronegativity pulls the electron cloud towards itself, thereby acquiring slightly negative charge, while the other atom acquires slightly positive charge. This makes the covalent bond a polar covalent bond. That's it. And not just that, the bond also acquires something which you call as a dipole moment. So the bond becomes a polar covalent bond and it becomes associated with something which we also call as a dipole moment. But we need not mention it because in this question, nothing has been talked about the properties of a polar covalent bond. This much is sufficient. Done.